In the fall of 1824, on a stretch of raised ground outside the village of Allanburg in Upper Canada, 200 people stood in the cold and watched a man break the first sod with a spade. There was no steam shovel behind him, there was no dynamite waiting in a shed. There would not be for another 50 years. What these people were there to start was a canal 27 miles long, cut through clay, sand, gravel and solid rock, that would climb over 300 feet from the shore of Lake Ontario to the surface of Lake Erie and carry ships around the one obstacle that no amount of ambition could dig through directly, Niagara Falls. The man who had spent 6 years fighting to get that crowd to that field was a mill owner from 12 Mile Creek named William Hamilton Merritt. He was not an engineer, he was not wealthy enough to fund the project himself, and the government of Upper Canada would not fund it for him. So he built a private company, sold shares to whoever would buy them, and set out to prove that a channel deep enough and wide enough for ocean-going schooners could be carved through the Niagara Peninsula using picks, shovels, oxen, and the backs of men willing to work for $50 a day. Merritt's original problem had nothing to do with shipping. His grist mill on 12 Mile Creek kept running low on water in the dry months, and his first idea, years earlier, had simply been to dig a short trench to divert a little more flow from a nearby stream. That small idea grew, year by year, into a plan for a full navigable waterway linking 2 of the Great Lakes, a plan far larger than anything a private company in Upper Canada had ever attempted. This is the story of how a mill owner's water problem became 27 miles of hand-dug canal, and what it actually took to put a shovel through that much ground. If you're enjoying this story so far, don't forget to hit the like button and subscribe. Drop a comment telling me where in the world you're watching from. I love hearing from you. Merritt's problem was not really about digging a trench. Digging a trench across flat ground was slow, brutal work, but it was work that any farmer with a shovel already understood. The real problem was elevation. Lake Erie sits more than 300 feet above Lake Ontario, and the land between them is not a smooth ramp. It rises through farmland toward a ridge called the Niagara Escarpment, drops again toward the Welland River, and rises once more before it reaches the shore of Erie itself. A canal that simply followed the ground would have needed a waterfall of its own, so the engineers Merritt hired laid out a route with dozens of locks, wooden chambers that would lift and lower boats a few feet at a time, stacked in sequence up and over the terrain like a staircase built for ships. Surveying that staircase in the 1820s meant walking the entire route with a chain and a leveling instrument, sighting elevation changes a few feet at a time across farmland, forest, and swamp, and marking a line on paper that hundreds of men with no engineering training would then have to translate into an actual channel in the ground. There was no way to check that line against satellite maps or aerial photographs. If the surveyors misjudged the grade in one stretch, the crews digging that stretch would not find out until the water was let in, and it either flowed the way it was supposed to, or it did not. The workforce that gathered to build this staircase was, in the early years, mostly local men, farmers from the Niagara district, who worked the canal in the months between planting and harvest. But the scale of the project outran the local labor supply almost immediately, and within a season or two, the crews filled out with immigrants, a large share of them Irish, arriving in Upper Canada with nothing but a willingness to swing a pick for wages that barely covered food and lodging. They lived in shanties along the route that moved as the digging moved, ate what they could afford, and worked from first light to last light because the company's shareholders were watching the calendar as closely as they were watching the ledger. $50 a day was the going rate for a man on a shovel, and out of that $50, he was often expected to cover his own board. Contractors who ran individual sections of the line competed for labor by offering slightly better food or a dry place to sleep, but the work itself did not change from one contractor to the next. It was the same pick, the same spade, the same cart, section after section, mile after mile, for as many daylight hours as the season allowed. The tools available to them in 1825 were almost embarrassingly simple: a pick to break the ground, a spade to lift it, a wheelbarrow or a horse cart to move it. Where the soil was loose enough, teams of oxen dragged scrapers, wide iron blades that could shave a few inches of earth at a time and pile it to the side. Where the ground turned to rock, there was no dynamite. Blasting powder existed and was used in some sections, but it was expensive, unpredictable, and dangerous to store and transport in the quantities a project like this would have required, so most of the rock along the route was broken by hand, wedge and sledge, hour after hour, man after man. Getting the spoil out of a channel that kept getting deeper was its own daily problem. Near the surface, a man could pitch a shovelful straight up onto the bank. Once the cut dropped 10 or 15 feet, that was no longer possible, and crews built staged platforms and ramps so the dirt could be relayed upward in shovel loads and cart loads from one level to the next, gang after gang passing material up out of the earth, the way a bucket brigade passes water. Every foot of depth added to the channel meant more men needed just to move the same amount of dirt the same distance to the surface. The section that tested every method they had was the stretch between Allanburg and Port Robinson, a ridge the engineers had to cut straight through because there was no way around it. It became known simply as the Deep Cut. The original plan was to tunnel beneath the ridge and let the canal pass through in darkness, but within weeks, the tunnel walls began collapsing under their own weight, and the engineers abandoned the idea and committed instead to an open channel, dug straight down through sand, clay, and shifting glacial till. By the time it was finished, the deep cut ran close to 2 miles long and dropped more than 40 feet below the surrounding fields, a man-made canyon carved entirely by muscle, wide enough at the top to lose sight of the men working its floor. Digging that deep into loose, waterlogged soil created a danger that no amount of experience could fully guard against. The walls of the cut were not solid rock. They were layered sand and clay that had never been disturbed since the retreat of the glaciers, and once exposed to open air and rain, those layers behaved unpredictably. Water seeping through the upper layers would loosen the ground from the inside, invisible from the surface, until the moment the weight above simply gave way. Sections would hold for weeks and then, without warning, slump. On the 9th of November, 1828, with the deep cut only weeks from completion, one of those walls gave way all at once, sending tons of earth down onto the men working the channel floor below, with no time to climb out and nowhere to run once it started moving. The exact number who died that day was never fully recorded. What the surviving accounts agree on is that it was not one man, and it was not a handful. It was enough that the collapse became the defining catastrophe of the entire project, and it forced the engineers back to their drawings to solve a problem they had not planned for. If you're hooked on this story, make sure to subscribe and turn on notifications so you never miss an upload. Your support means everything and helps me bring you more emotional stories like this one. That problem turned out to be bigger than the landslide itself. The deep cut had been designed to draw its water from the Welland River, but the collapse revealed that the ground could not be cut deep enough to reach that water source without risking further failures like the one that had just killed their own men. The engineers were forced to abandon that plan entirely and look elsewhere for a supply of water large enough to keep the canal full. They found their answer 30 kilometers away, at the Grand River, well above the elevation the original survey had counted on, and set the crews to work on an entirely new feeder canal to carry that water east to the summit of the Welland route. Building the feeder meant surveying and digging a second waterway almost from scratch, complete with its own dam on the Grand River, to raise the water high enough to flow downhill into the summit level of the main canal. None of this had been part of the original plan or the original budget, and it meant more miles of hand digging that Merritt's shareholders had never agreed to fund, added onto a project that was already years behind its own optimistic timeline and bleeding money the company did not have. While the feeder crews dug their new channel, other gangs were working 40 separate lock sites along the main line, and each one was its own small feat of carpentry as much as excavation. These were not stone locks. They were built from hand-hewn timber, squared logs and planks fitted and pinned together to form chambers roughly 110 feet long and 22 feet wide, strong enough to hold back the weight of water needed to lift a loaded schooner several feet in a matter of minutes. Building one meant excavating a pit to the exact depth and shape of the chamber, driving timber piles into the floor to keep the whole structure from shifting under the water's weight, and then framing the walls up around that foundation log by log, all of it fitted by hand with augers, adzes, and saws rather than any standardized parts. Every gate had to be built tight enough to hold water under pressure and light enough for two men to swing open by hand, using long wooden balance beams that acted as levers against the pressure of the chamber. Getting that balance right, in wood, without the benefit of any prior Canadian experience building canal locks at this scale, was its own quiet engineering achievement that rarely gets mentioned alongside the deep cut. A gate built too heavy would jam and stall every boat behind it. A gate built too light would not hold against the water pressing on the far side, and the lock keepers who eventually operated these chambers had to learn, largely through trial and error, exactly how much force it took to work each one. By the summer of 1829, 4.5 years after that first spade broke ground at Allanburg, the pieces were finally coming together. The feeder canal from the Grand River was open and pouring water into the summit level. The deep cut, rebuilt and stabilized after the collapse, held its walls. The 40 timber locks stood finished along the route from Port Dalhousie on Lake Ontario down through 12 Mile Creek, Thorold, Allanburg, and Port Robinson, out to the Niagara River and Lake Erie beyond. On the 7th of November that year, the first boat passed through the deep cut and reached the Grand River feeder, and word spread along the works that after everything, the water was actually going to hold. The formal opening came on the 30th of November, 1829. Two schooners, the Annie and Jane and the R.H. Broughton, entered the first lock at Port Dalhousie and began working their way south, rising through lock after lock. The same men who had dug the channels, now standing along the banks to watch their work, carry an actual ship. It took the schooners roughly 2 days to cross the full 27 miles and reach open water on Lake Erie, a trip that would have meant hauling cargo overland around Niagara Falls for anyone who had tried it a decade earlier. Merritt himself sailed on the Annie and Jane. The men who had broken the ground, hauled the carts, and buried their friends after the deep cut collapse were, for the most part, already gone, moved on to the next job, or simply lost from the record the way canal labourers so often were in this era. What the canal did for the region afterward was immediate and hard to overstate. Grain, lumber, and goods that once had to be portaged around the falls on wagons could now move by water in a fraction of the time and at a fraction of the cost. Towns along the route, St. Catharines, Thorold, Welland, grew from mill villages into shipping and manufacturing centres almost overnight, their growth powered in part by the same water that had once been dug through by hand. Merritt's original ditch, meant only to keep his own gristmill wheel turning through the dry months, had become the backbone of trade between two Great Lakes, and within a few years it was already too small for the ships that wanted to use it, which set off a second wave of digging in the 1840s that widened and deepened almost everything the first crews had built. None of it happened without a cost that the shareholders' ledgers never fully tallied. The men who died in the deep-cut collapse, the ones who succumbed to fever in the shanties along the route, the ones who were simply hurt badly enough to disappear from the payrolls, left almost no trace in the official record of the Welland Canal Company. Their names were not carved into the locks they built. What survives instead is the physical evidence of the work itself. The deep cut still runs today as part of the modern Welland Canal, the only stretch of the original alignment still carrying ships more than a century and a half after it nearly collapsed in on the men who dug it. Powered excavation eventually replaced every method these crews relied on. Steam dredges and mechanical shovels rebuilt the canal twice more over the following century, each rebuild wider and deeper than the last, engineered to standards the 1825 surveyors could not have imagined, and built by machines that could move in an hour what a hand crew needed a week to shift. Where the second and third canals eventually straightened or bypassed the original line, the old channel bed was left behind in the landscape, and walking those abandoned stretches today, overgrown and quiet, is the closest thing left to standing where the diggers actually stood. But the route those later machines followed, the ridge they cut through, the elevation they climbed, all of it still traces back to the line a handful of surveyors staked out through Niagara farmland 2 centuries ago, and the 27 miles that thousands of men, with picks and shovels and $50 a day, actually dug into the ground with their own hands. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.